Ratios overview. We'll go through all this in more detail. This is just to let us know what we're doing with ratios for the next little while. Ratios compare similar amounts. So when I say similar, if I'm asked to give the ratio of dogs to cats in this situation, dogs to cats, 3 dogs to 2 cats. Now, while dogs and cats aren't very similar, we're counting things. If they asked me to give the ratio of cats to dogs, then that would be cats to dogs, and we'd do this in the other way. So these are just simple ratios comparing the number of cats to the number of dogs. Here's a one, maybe it's the start of a recipe. I need 2 cups of water and 5 cups of flour. Because they're both cups, I can compare those in a ratio. The ratio of water to flour would be 2 to 5. They could ask for the ratio of flour to water, that would be 5 to 2. And what this is saying is, if I've got 2 cups of water, sure, I'll have 5 cups of flour. But I could change the recipe up. I didn't have a cup, I've only got a half cup. I could use 2 half cups of water and 5 half cups of flour. If I wanted to make a really small cake, 2 teaspoons of water and 5 teaspoons of flour. So a ratio gets rid of the units because it will then work for any amount. 7 centimetres to 3 metres. Now these are different, but I could write 3 metres as 300 centimetres, and then I could say, well, that's 7 to 300. So it's comparing this. I don't know, maybe I knitted 7 centimetres of a scarf in the same time as my friend knitted 3 metres of a scarf. The ratio of what we did is 7 to 300. I could probably use that to solve problems. If we knitted for 3 times as long, I might manage 21 centimetres and she might manage 900 centimetres. So ratios can get used to make predictions as well. Now this can't be made into a ratio. 1 litre of something and to 3 square metres, 6 square metres. These are not the same thing. Litres and metres squared, whatever they are, that's not the same. I can't make a ratio out of things that aren't similar. We'll get back to what this is because I can make a rate out of this but not a ratio. Now ratios can be simplified the same way we simplify fractions. Here's a ratio of 3 to 12. Maybe for every 3 pencils I've got in my pencil case, there's 12 pens. The way we simplify fractions is to look for the highest common factor. 3 goes into both of these, so I'm going to divide both sides by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. For every 1 pencil in my pencil case, there's 4 pens. Simplifying this one, 10 and 8. The highest common factor, the biggest number that goes into both, is 2. 10 divided by 2 is 5. 8 divided by 2 is 4. So we simplify ratios the same way we simplify fractions. And in fact, fractions and ratios are very, very similar. Ratios can also be used to solve problems. Tim and Joanne cleaned the yard. Tim worked for 4 hours and Joanne worked for 6. They got paid $50 in total. How should they split it? Write a ratio, Tim to Joanne. Tim worked 4 hours, Joanne worked 6. Can we simplify this ratio? 2 goes into both of these. This is 2 to 3. So this is saying if Tim worked 2 hours, Joanne worked 3. If we have $50, think of the ratio as parts. Tim deserves 2 parts of the money. Joanne deserves 3 parts of the money. So we need to add those parts. There's 5 parts in total. Now 1 part I've got $50, I've got to divide it into 5 parts. One part is $10. Tim gets 2 parts, so Tim gets 20, Joanne gets 3 parts, Joanne gets 30. So that's how we can use ratios to solve problems. We'll go through all these aspects of ratios next term, or later on, but this is just an overview.